Hello and welcome to problem 332. This one we have two spinners. One of them says the initial amount of money, and the next one tells you whether you can keep your winnings or double your winnings. These are independent, so I could do an area model. However, I'm going to do a tree diagram on this one. So it should look like this. The first spin is going to be about our winnings. We could win 100, we could win 300, or we could win 1,500. And then on your second spin, either you can keep your winnings or double them. Keep or double, keep or double. This is what your tree diagram should look like. Now let's put our money values on here. If we win 100 and we get to keep it, that means we get 100 bucks. If we win 100 and double it, now we're up to 200. 300 and we keep. 300 and we double. 600. 1,500 we keep, 1,500 we double. Now the first question says, we did this, are each of the outcomes in the sample space equally likely? And the answer is yes, because they're not weighted. Each of these have a 1/3, each of these has a 1/2, each of the final outcomes each are 1/6. Part C, what's the probability you'll take home $200? And then what's the probability that you'll take home more than 5? Let's answer the 200 first. Let's come back here and look. Which of these would give us exactly $200? Just this one. So the answer to part C, the probability of winning $200 is 1 out of 6. The second part of the question says, what's the probability we'll take home more than 500? And that would be here the 600, here the 15, here the 3,000. So that's 3 out of 6, which we can reduce to be 1/2. Part B, what's the probability you will double your winnings? Or, sorry, D. So probability that it's doubled, which ones are doubled? This one, and this one, which is 3 out of 6, which is 1/2. Does the probability that you will double your winnings depend on the result of the first spinner? No, those are independent events. The first one doesn't depend on the second one. And the last one for E, what if the amounts on the first spinner were 100, 200, 1,500? So if this changed to be 200, then we would keep this and we would keep 200, or we would double it and it would become 400. The question asks, what's the probability you would take home 200? Well, now that could be here or here. So that's 2 out of the 6. So the probability of 200 changes now to be 2 out of 6, which simplifies to be 1/3. Have a great day.